Moving to number 5. All right, this is where we got to be careful. It says, what is the volume? So we're looking for volume over here. All right, what is the volume of a substance that has a mass of 90 grams and a density of 10.5 grams per cubic centimeters? All right, if I drew out my little circle right here, I'd put my mass up top and then Death Valley down below. And I'm looking for volume, so that's the one I would cover up. I'd cover up the V, and it tells me my equation is going to be mass divided by density. So volume equals mass divided by density. If you wanted to do the algebra way of solving that, you could start off with our original question, density equals mass divided by volume. And if I wanted to get that volume by itself, I'd have to get it up top first. So I'd multiply both sides by volume. You know, if I multiply the top by volume, and anything you do on the right hand side, you have to do on the left hand side as well. So this volume up top being divided by volume, they would cancel each other out, and I would have mass equals distance times volume. But that's not what I want right there. I want volume by itself. So I would divide both sides by density. I got volume times density equals mass here. I would divide both sides by density, and then these densities would cancel each other out because of density divided by density, cancel each other out. And I'm just left with volume equals mass divided by density. I'm just showing you the algebraic way, but volume equals mass divided by density, that's the same exact thing we got using the circle diagram. You can use whichever method you're more comfortable with at this point. I would probably stick with the circle diagram. It's much more easier to work with that, especially when you're doing a lot of these problems. But after we have our equation, we just plug the numbers in where I have mass of 90. So I'll put 90 grams at the top. And I have a density of 10.5 grams per cubic centimeter, which density is down here. So we have 10.5 grams per cubic centimeter. And then we just plug in a calculator. We have 90 divided by 10.5 equals, and we'll just round this. It says 8.5714285. Let's just round this to like 1.57. All right. Even if you ran it to 8.6, I would still mark you correct. And in fact, 8.6, if we use significant figures, would actually be more correct. So let's go 8.6. And then what would be our units there? If we're dealing with volume, the answers are going to be either milliliters or cubic centimeters, depending on whether we're talking about a solid or a liquid. Well, in this case, up in the equation, it told us that we're measuring things in cubic centimeters. So just put centimeters cubed there, and you're done. All right, 8.6. Now remember, this is volume. That's what we're solving for. I cannot use my answer right here to go and look for an answer up here up top, because this is not a volume chart. This is a density chart. And so when you get to number 6, and a lot of students made problems with this one, it says, what is the name of substance in question 5? Well, the students would go and look at the answer, but you can't use that answer up top. This is the volume. You can't use volume in a density chart. What you would look at is right here where it says density of 10.5. It's right in the question. It tells you what the density of that object is. And so we're looking for 10.5 grams per cubic centimeter, because this is what the density says, and a density of 10.5. That's what you use in the density chart, is the density. So if we come back up here to the top, we look for 10.5 grams per cubic centimeter. Well, there it is right there. It's going to be silver. All right.